Hi, I'll be showing how you can use the area under a function to simplify the evaluation of definite integrals for some functions. So what I'm saying is that the integral, okay, give me one, integral of a function f of x dx from x0 to x1 is equivalent to let's assume the curve, let's assume this is f of x, and this is x of 0, x of 1. This is equivalent, the integral of this is equivalent, the evaluation of this definite integral is equivalent to this area. So this area. So that's what we're trying to show, or we're trying to use to simplify the evaluation of definite integral. But then it works for certain definite integral, because if the shape doesn't have an easy formula for the area, then there's no easy way of evaluating this area, right? Because you can see all these points are not, it's not a constant or a straight line, so it's not easy to find the area, or there's no simple enough formula for this area. So, but certain shapes or functions have shapes that have known formula for the area. So we're going to use that. Now, we know this already. I'm going to use this to solve a question. If you have the integral, if you're asked to find the integral of square root of 2x minus x squared dx from x equal to 1, so this is my x0, or sorry, 0, and then to x equal to 1. How can I use knowing this to solve this? If you're going to solve this definite integral, you're going to first complete the square, and then secondly, I would have to use trig substitution. But let me see if I can use the area under this function. So I'm going to equate this function to y and see if I can get the formula, a simpler shape or formula that can be, sketched. So I'm going to say, okay, let this be equal to y. So now I have y is equal to square root of 2x minus x squared. If I square both sides, I will have y squared equal to 2x minus x squared. I've eliminated the square root. If I rearrange a bit or complete the square on the right hand side, I can look for something that can be added, a constant that can be added to the right hand side or subtracted. So I think if I subtract 1 from the right hand side, to keep the equation true, you have to do both. You have to add or subtract the same number from both sides. So that's why what I'm trying to show is that this portion is now a perfect square. Now, one thing I'll do to make it more obvious is to factor out minus 1. So x squared minus x squared becomes x squared. 2x becomes minus 2x, and minus 1 becomes 1, right? Now you can see that this is a perfect square. So I have minus outside, and this is x minus 1 squared. Perfect. So now I have y squared minus 1 is equal to minus x minus 1 bracket x minus 1 squared. So I can bring all the terms with variables to the right and to the left hand side. So I'll have y squared plus x minus 1 squared is equal to 1. So this is a standard form for a cycle, for a circle. If you're familiar with circles, you will recognize this as the shape of a circle. The general form for circles is the general form for a circle is y minus, or let me not start with y. The general form for circles are x minus a squared plus y minus b squared equal to r squared. So if I write this underneath, so x minus 1 squared plus y minus 0 squared, that's just what it is, right? Equal to 1 squared, because 1 squared is 1. What this means is that a is 1, b is 0, b is 0. Now, this is the general form for a circle where r is the radius of the circle, a and b are the center of the circle. So let's see, I don't have much room and I don't want to delete everything. So I'm just gonna take this part off because I don't want to delete the formula up there. Okay, so let's sketch this circle now that we know that A is equal to 1 and A is the value of X at the center of the circle and B is the value of Y at the center of the circle. R square is just the radius square. So if R square is equal to 1 square, that means the radius R is 1. So we have the center of the circle, center, coordinate for the center, and then we have the radius, right? So if you, that's all the information you need to sketch a circle. So I'm going to sketch it now. Let's assume, let me just draw the y coordinate, the x, the y, the x. Let me see if, okay, I have a shape here. I'm just going to use a perfect shape from the library of shapes. So this other line is not vertical, but ignore. So now this is your 0, this is your y, this is your x. Now the center is here, which has coordinate 1 for x and 0 for y. And then the radius of this circle is r equal to 1. Now we are trying to find the evaluation or the value of that function square root of x 2x minus x squared dx from 0 to 1. So we know we want to find it from 0 to 1. So I'm just going to draw a line here. So if I was going to find, so this is the area I'm interested in. It is only the positive half because this square root gives the positive half. I should have used a different color for that. So this represents the evaluation of this. So positive half because there's a square root. If there's no square root, then it's no longer a circle. But positive half because it is the square root is the positive half and ranging from 0 to 1. And what is the area of a circle? The area of a circle is what? The area of a circle is equal to pi r squared, but this is just the quarter. The area we're interested in is the area of a quarter of the circle, so we divide by 4. So what that means is that this area will be pi. The radius is 1, so 1 squared divided by 4. So this will simply give me pi over 4. So yeah, you see how simple it is to evaluate. Again, I'm explaining, so it takes time. So I'm just going to summarize this. I'm going to summarize this. I'll delete a couple of things. The in between. Yeah. So delete this. I'm going to. Okay. Just copy this for now and delete this. Okay, so now I'm going to summarize what we just solved from top to bottom. So if you are asked to integrate or find the definite integral of square root of 2x minus x squared dx from value 0, lower limit of 0, upper limit of 1. This is equivalent, so let me move this down a bit. This is equivalent. This is equivalent. This is equivalent to, I copied it earlier, to this. So this is equivalent to this. A circle, but we're just interested in that quarter. And the area of a circle is pi r squared, but then we're interested in 1/4 of the area, so divided by 4, right? And then this gives us pi. Remember, we already got the radius as 1 squared divided by 4. So this will give me pi divided by 4. So that's the summary of all that. I hope this was helpful. Thanks for watching.